everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम क्वांटिटेटिव एप्टीट्यूड की क्लास करने वाले हैं जो कि क्लास नंबर 6 है. ऑलरेडी हम दैट इज़ ऑफ 5 क्लासेस हम कर चुके हैं क्वांटिटेटिव एप्टीट्यूड के, जिसमें हमने अरिथमेटिकल एबिलिटी स्टार्ट कर दिया. दिस इज़ द फर्स्ट टॉपिक, दिस इज़ द फर्स्ट सेक्शन वेयर वी हैड स्टार्टेड विद द ऑपरेशंस ऑन नंबर्स हियर. And instead of these we had done many of the questions related to the operations of numbers as well in the quantitative aptitude. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe to our channel so that many maximum people can get the information at once, and even you can also enjoy the video as well. Let's go ahead with the question that what we have to discuss here. Lastly, we had done MBA examination paper, so we'll start with MBA questions that has been asked here in the competition. Let's go ahead with the sessions. The first question of the session here. 155 question of the session, that what we have to talk about it. The question is, if n is a natural number, then 6n square plus 6n is always divisible by. The options we have 6 only, 6 and 12 both, 12 only and by 18 only. And that has been asked in MBA examination paper. So let's go ahead here. If n is a natural number, then 6n square plus 6n is always divisible by. That has been asked in MBA question paper, which is important. Let's go ahead with solution as well. As I told you, the options we have 6 only, 6 and 12, 12 only and 18 only here. So in the terms of it, we'll go ahead as well, which is your 104th, that is your 155th question of the session. So here we have, that is your 6n square plus 6n plus equals to 6n and plus 1, which is always divisible by 6 and 12, since n plus 1 is always even here. So that is the 6 and 12 both will be the right answer for this question here. Now we'll go ahead with other question, that what we have to talk about it, which is 156th question of the session. The question is, n is a whole number which when divided by 4 that gives 3 as remainder. What will be the remainder when 2n is divided by 4 here? That we have to go through with that. The options we have 3, 2, 1 and 0. So the questions we have, n is a whole number which when divided by 4 gives 3 as remainder. What will be the remainder when 2n is divided by 4? The options we have 3, 2, 1 and 0. So here we go ahead with the solution as well, that what we have to talk about it. So according to these particular questions, we have to go through with that, and the solutions we have here, that is your, let n equals to 4q plus 3, then 2n equals to 8q plus 6, that is equals to 4, 2q plus 1 plus 2. Thus, when 2n is divided by 4 and the remainder is 2n is divided by 4 and remainder 2. Now we'll go ahead with other question. That what we have is your 157th question of the session. Let's go ahead with that as well. 157th question of the session here. That is, what will be the remainder when 67 power 67 plus 67 is divided by 68? The options we have 1, 63, 66 and 67. The question is, what will be the remainder when 67 power 67 plus 67 is divided by 68? The options we have 1, 63, 66 and 67 here. In the same cases, that what we will be solving out and will be finding out as well as the answers as well. So that is we will be going ahead, and that here for that particular questions, the solutions we have, which is xn plus 1 will be divisible by x plus 1 only when n is odd. 67 power 67 plus 1 will be divisible by 67 plus 1. So where 67 power 67 plus 1 plus 66, that when divided by 68 will give 66 as a remainder. Now we'll go ahead with other question, that what we have to talk about it here, and that is another question of the session, and which is also plays an important role as well while solving it out here as well. That is your 158th question of the session. So here, which of the following number will be completely divided by 49 power 15 minus 1? So we have to tell it out about, that is which of the following number will completely divide 49 power 15 minus 1. The options we can give here 8, B is 14, C is 48 and D is 50. So in the same case we'll solve it out as well, which we have xn minus 1 will be divisible by x plus 1 only when n is even, and 49 power 15 minus 1 equals to, that is 7 power 15 minus 1, which is equals to 7 power 30 minus 1, which is divisible by 7 plus 1, and that is 8. Now we will go ahead further, and that what we discussed about it, which is the another question here, that x power n, which is your 159 question, x power n minus a power n is completely divisible by x minus a. So when the options we have, n is any natural number, n is an even and natural number, n is an odd natural number, and n is a prime. So here we have to solve accordingly. So for that, for every natural number we have n, that is your n, xn power minus an, that is always divisible by x minus a here. Now we will go ahead with other question, that is your 160th question of this session here, that what we have to talk about it. So in the same cases, we will go ahead, what will be the remainder when 17 power 200 is divided by 18. This has been asked in SSC examination paper. So what will be the remainder when 17 power 200 is divided by 18, which has been asked in SSC examination paper? The options we have 17, 16, 1 and 2, so that we have an answer. Let's go ahead with the questions that we talk about it as well, which where we will talk about the solution for this, which is here. And when n is even, xn minus a power n is completely divisible by x plus a, and 17 power 200 minus 17, that is your 1 power 200, is completely divisible by 17 plus 1, that is your 18. And that is your 17 power 200 minus 1 is completely divisible by 18. Only dividing power 200 by 18, we get 1 as remainder. Now we will go ahead with further one, and that is another question, which is your the 161th question of the session here, and that is also an important one with reference towards the competition wise, and that is also being very important. Which one of the following is a common factor? You have to tell which one of the following is a common factor of 47 power 43 plus 43 power 43 and 47 power 47 plus 43 power 47 here. The options we have 47 minus 43, 47 plus 43, 47 power 43 plus 43 power 43, and none of these. So here we go ahead with the solution, and that what we have to solve it out. So here, when n is odd, then xn plus a power n is always divisible by x plus a. So here each one of 47 power 43 plus 43 power 43 and 47 power 47 plus 43 power 43 is divisible by 47 plus 43. So that is the right answer of 47 plus 43 here. Now we'll go ahead with other questions. So the other question we have is your 162th question of the session, that what we have to talk about it, and which is that it is being given that 2 power 32 plus 1, and that is completely divisible by a whole number, and which of the following number is completely divisible by this number, that you have to tell, and that has been asked in SSC examination paper. So that is also an important one. We'll give you an option, that is 2 power 16 plus 1, 2 power 16 minus 1, 7 into 2 power 33 and 2 power 96 plus 1. So according to that, what we have to solve it out as well here. So in the same references that we'll go ahead, which is that the solutions of this, and that what we have here is to be as follows, which is your let 2 power 32 be equals to x, then what it will be, 2 power 32 plus 1, which is equals to x plus 1 here. So let x plus 1 be completely divisible by the natural number, which is n. Okay, so in the same cases here, that then 2 power 96 plus 1 equals to 2 power 32 power 3 plus 1, that is equals to x cube plus 1 equals to x plus 1 x square minus x plus 1, which is completely divisible by n here, and since x plus 1 is divisible by n. Now we'll go ahead with other question, that is your 163rd question of the session. Now we'll go ahead with 163rd question of the session here. In this we'll talk about it, that which one of the following numbers will completely divide 4 power 61 plus 4 power 62 plus 4 power 63 plus 4 power 64 as well. The options we have 3, 10, 11 and 13. So 112 the questions as well, that what we have to solve it out here, which is in the same following manner. We are in the same representation of this question. We will go ahead with 4 power 61 into 1 plus 4 into 4 power 2 plus 4 power 3, and that is equals to 4 power 61 into 85, and then that is equals to 4 power 60 into 4 into 85, which is equals to 4 power 60 into 85 fours, which is 340, which is divisible by 10. That is the answer we have here, that will be that is divisible by 10 as well. So let's go ahead with other question, which is your another one, and that same case, which is your 164th question of the session. Which of the following number will be completely divide 3 power 25 plus 3 power 26 plus 3 power 27 plus 3 power 28, and that we have to find out. The options we have is 11, 16, 25 and 30. So we'll go ahead with the solution here as well. So in the same cases, that the question that has been represented here, and in the same case we have 3 power 25 into 1 plus 3 square plus 3 cube, which is equals to 3 power 25 into 40, and that is equals to 3 power 24 into 3 into 4 into 10, that we had break the 44 into 10, and 3 power 25 is your 3 power 24 and into 3 here as well. So with the same case we'll go ahead with 3 power 24 and into 4 into 30, 3 tens are 30. So that is which is divisible by 30. So yes, we can say that that the answer would be your 30 here as well. So that has been the 30 has been the number that has been completely divide this particular number, this particular question. We'll go ahead with other question, that what we have, and that is your 165 question of the session. The question I will write it down and a solution will do ahead. 165 question. So the question is, a 3-digit number 4A3 is added to a number 3-digit number which is 984 to give a 4-digit number 13B7, which is divisible by 11. Then A plus B equals to what? You have to tell. So let's go ahead with question. A 3-digit number 4A3 is added to another 3-digit number that we have, and that is that another that has been added into the another one, and that is to give the another 3-digit number 984 to give a 4-digit number. So here we go ahead with 166th question, as we get to know A plus B equals to 10, And in the 166 question, where with that is your, if x and y are positive integers, then such that 3x plus 7y is a multiple of 7, then which of the following will be divisible by 11? And the options we have 4x plus 6y, and x plus y plus 4, and 9x plus 4y, and 4x minus 9. So among these questions we have to solve it out. Let's go ahead with the question here. If x and y are positive integers such that 3x plus 7y is a multiple of 11, then which of the following will be divisible by 11? So that is what we have to go through with that. And the options, as I told you, 4x plus 6y, x plus y plus 4, 9x plus 4y, and 4x minus 9y. So we'll go ahead with the solution here, which is, we have, by the hit and trial, we put like x equals to 5, and that is, and y equals to 1, so that we have 3x plus 7y in this. So what we'll get is 3 into 5 plus 7 into 1, so that is, we'll get 22. So 5 is 15 plus 7, 1 is 7, so 15 plus 7, that is 22, which is divisible by 11. Okay, that is divisible by 11, that we had done hit and trial here. In the same cases, further we go ahead, which is your 4x plus 6y, which is equals to 4 into 5. We had put x equals to 5 and y equals to that 1 here. So 4 into 5 plus 6 into 1 will get 28. So that is not divisible by 11. The third we take as, that is your, the third option, which is x plus y plus 4. So in this, 5 plus 1 plus 4, which is equal to 5 plus 1, this is 5, 5, 10. So 10 will get, which is not divisible by 11. The next option we have is your 9x plus 4y, which is equals to 9 into 5 plus 4 into 1. So 5 9s are 45, and 45 4 1s are 4. So 45 plus 4, which is equals to 49. That is also not divisible by 11. Other option we have is your 4x minus 9y, which is equals to 4 into 5 minus 9 into 1. So 4 5s are, that is 20, and 9 1s are 9. So that 20 minus 9, we will get 11. So that is divisible by 11 as well. So here that the options that is we have, here we will get here is 26, that is not divisible by 11. So that is, with the option we have 4x minus 9y will be suitable for this, and that is divisible by 11. So that will be the right answer for this question here. We'll go ahead with further one, and that is another question we have, and that is your 167th question of the session. The question itself says that if the number 653xy is divisible by 90, then x plus y is equals to question mark. So let's go ahead. If the number 653xy is divisible by 90, then x plus y equals to question mark. The options here we have, which is 2, 3, 4 or 6. So among these questions we'll go ahead with the solution. That is, so 90 will break into 10 into 9. So clearly 653xy is divisible by 10, so y equals to 0. And now 653x0 is divisible by 9, so 6 plus, that is 5 plus 3 plus x plus 0, which is equals to 6 plus 5, that is your 5 plus 3 8, 8 plus 6, and that 8 plus 6 we have 14, so that is 14 plus x. So that is divisible by 9 as well. that is 14 plus that x by 9 here, and so that we can say here that is x equals to 4, and in the same references we say that x plus y equals to 4 plus 0, and that is equals to 4. Now we'll go ahead with other one, that is another question here, and that we have is your how many of the following numbers are divisible by 3 but not by 9. So the number of the series, we'll talk about it, which is your 168 question of the session. So I'll just write it on the number 2133, 2343, 3474, 4131, 5286, 5340, 6336, 7347, 81159276. The options for this, the 5, 6, 7 or none of these. You have to see that how many of the following numbers are divisible by 3 but not by 9 here. We will solve that. We will be going ahead as well that we solve it. Let's go ahead. That marking the tick those which are divisible by 3 but not by 9, and the other that will be crossed by taking here. So in the same cases, that 2133 that is by 9, so that will not take. That is another one, 2343, the sum of the digits we get, so that will get some of the digits here. It will be 9, so it is not. It will be 12, so yes, it will be. The 3474, it will be, so that is it, the sum of the number is 18, that will cross. The other one we have your 4131, that is divisible by 9, sum of that is here in the same references, and that is your 4 by 3 by 9, that is your, of course it will not. And the other we have 5286, the sum of the number we have 21, so it will be. The other we have 5340, the sum of the number we have 12, so yes, it will be. The other we have is your 63 and 36, that the sum of the number is 18, so yes, it is not. The other number we have 7347, that yes, the sum of the number we have 21, so it will be. And 8115, so the sum of the number we have 15, so that it will be. Another number is your 9276, the sum of the number we have your 24, that it will be. So the required numbers of number that is equals to 6 here. So total number of yes is your that is 1 2 3 4 5 and 6, so that we have 6 required number of numbers is just 6 here. Now we'll go ahead with other one, that is the another question, and that is your 169th question of the session. In this, which of the following number is divisible by each one of, that is your 3, 7, 9 and 11. So in this, the options we have 639, 2079, 3791 and 37911 here as well, and the option is none of these. So among these we have to solve it out. $639 is not divisible by 7, and 2079 is divisible by each one of 3, 7, 9 and 11. Now we'll go ahead with other question, which is your 170th question of the session. That what we have to talk about it, and that we have as to be follows. The question that we will be going ahead to solve it, and that is on these particular question. The another question we have, how many of the following numbers are divisible by 132? We have to talk by 132, so that is we have 264, 396, 462, 792, 968, 2170. This has been asked in the hotel management question paper, so that we'll discuss here, and which is your 119th question of the session, and that what we talk about it, and we'll go ahead with the solution as well, and that what we have to discuss, which is your 132 is equals to 4 into 3 into 11, and for the 264 we have, which is equals to 11, 3 and 4, so that it will be yes. In 398 96 we have 1 11 3 4 yes. Other we have here is your, that is 462, so for that 11 3 yes. For 792 we have 11 3 4 yes. The other we have 968, and for that will be 11 and 4. For that cross, that is not. That is another one we have is your, that is 2178, which is that is your 11 and 3, which is cross. That is not possible. For 5184 it will be 3 and 4. For that is cross. 6338, that for them it is 11 3 4. For them yes it is. So the required number of numbers that we have is equals to, that is your 4. Let's go ahead with other question, which is your 171th question of the session, that what we have to discuss here. In the same cases, that a number when divided by 6 that leaves a remainder 3, and when the squares of the numbers is divided by 6, the remainder is, that you have to find out. The option is 0, 1, 2 or 3. I will write a question for you. A number when divided by 6 leaves a remainder 3 when the square of the number is divided by 6. The remainder is, that what we have to find out. So let's go ahead with the solution as well, which we have. Let x equals to 6 cube plus 3, then x square equals to 6 cube plus 3 square, which is equals to 36 cube square plus 36 cube plus 9. When we take 6 common in them, then we will get 6 cube square plus 6 cube plus 1 plus 3. And that is, thus when x square is divided by 6, then remainder 3 we get. Now we'll go ahead with other question, and that is the another one, which is your 172th question of the session here. Let's go ahead. So in the terms of 172th question of the session, that what we have to talk it, that is the question we have. A number when divided successfully by 4 and 5 leaves remainder 1 and 4 respectively. When it is successively divided by 5 and 4, then respective remainder will be. This has been asked in SSC examination paper. So let's go ahead with this. A number when divided successively by 4 and 5 leaves remainder 1 and 4 respectively when it successively divided by 5 and 4, then respective remainder will be. That has been asked in SSC examination paper. The options we have 1 and 2, 2 and 3, 3 and 2, and 4 and 1. Let's go ahead with the solution that what we have to go ahead. So here for them we have a solution here, which is 4 x 5 y minus 1, that is your 1 minus 4. In that same case we can say that y equals to 5 into 1 plus 4, which is equals to 9. 5 on the 5 plus 4, that is 9 here. So x equals to 4 into y plus 1, which is equals to 4 into 9 plus 1, and equals to 37. Okay, that is 9 for the 36 plus 1, 37 here. Now 37 when divided successively by 5 and 4, what we get? 37 when divided successively by 5 and 4, we get, what we get is, that is 37 5, so that is 7 minus 2. 5 7s are that 35, that minus 2, so that is 5 2s are 10. So that will multiply and then we'll minus it out, we get it out as well. 4 1 minus 3, that we have. Now in the respective manner, the respective remainders will be 2 and 3. Or 2 and 3. Now we'll go ahead with other question, which is your 173rd question of the session. So the question is that a number when divided successfully, that we had done. Okay, the other question is that a number was divided successfully in order of 4 5 6. The remainder were respectively 2 3 4. The number is, you have to find out. Options we have 214, 476, 954, and 1908. So here we go ahead with question. A number was divided successively in order by 4, 5, and 6. The remainder were respectively 2, 3, and 4. The number is, so let's go ahead with solution, which we have, which is x, that is 4 5 y minus 2 6, it is your z minus 3 here. Here we go ahead with this, and that is your we'll talk about it, which is z minus 3, and then we have 1 minus 4 here. So for that is z equals to 6 into 1 plus 4. 6 1 the 6 plus 4, that is 10. Then y equals to 5 multiply z plus 3, which is multiply 10 plus 3, which is equals to 53. X equals to 4 into y plus 2, which is equals to 4 into 53 plus 2, that is equals to 53 4 is 212 plus 2, and that is equals to 240. So we go ahead with the required number, equals to 240. That will be the right answer. Let's go ahead with other question, which is your another one, which is your 174th question here. That will go ahead. The question we have, in dividing a number by 585, a student employed the method of short division. He divided the number successfully by 5, 9, 13, that is your factors of 585, and got the remainder 4, 8, 12 respectively. If he had divided the number by 585, the remainder would have been, the option is 24, 144, 292, and 584. Let's go ahead with the question. That first I will write it down for you. that is in dividing a number by 585, a student employed the method of short division he divided the number successively by 5, 9 and 13, that is the factors of 585, and got the remainder which is 4, 8, 12 respectively. If he had divided the number by 585, the remainder would have been, option is 24, 144, 292 and 584. So let's go ahead with the solution that we have. So 5x, that is 9, y minus 4, 13, that is z minus 8, 1 minus 12. So in the same case we have z equals to 13 into 1 plus 12 equals to 25, y equals to 9 into z plus 8 equals to 9 into 25 plus 8 equals to 233, x equals to 5 into y plus 4, that is equals to 5 into 233 plus 4, which is equals to 169. Now we'll divide it 589, that is 1169 by 585, and then we'll get the answer as well. So here we go ahead. Five ones are 585, which is 584 we'll get here. So that will be the answer on dividing the number 585. The remainder will be that is 584. Okay, so that it will be the answer. Let's go ahead with other question, which is your 175th question of the session here. Now we'll go ahead with 175 question of the session, that is when a number is divided by 13, the remainder is 11, and when the same number is divided by 17, the remainder is 9. What is the number? So when number is divided by 13, the remainder is 11. When the same number is divided by 17, the remainder is 9. What is the number? Options we have 339, 349, 369 and data inadequate. So we'll go ahead with the solution of these particular questions here. So with the same cases, here we go ahead, which is x equals to 13p plus 11 and x equals to 17q plus 9. So in the same references, 13p plus 11 equals to 17q plus 9, and that is equals to 17q minus 13p, that is equals to 2. So where q equals to 2 plus 13 p upon 17. So the least value of p for which where the q we have equals to 2 plus 13 p upon 17 is a whole number where p equals to 26, and for that we have x equals to 13 into 26 plus 11, which is equals to that is your 338 into 11, and that is equals to 349 here. Now we will go ahead, and that we have to discuss as well, that is your plus here, that is plus here, so that is your 349 here as well. Now we'll go ahead with other question, which is another one, and that is just 176th question of the session here. So the 176th question of the session, the question is, a number when divided by 298 leaves 75 as remainder, and when the same number is divided by 37, the remainder will be. This has been asked in the CBI question paper. So that is, a number when divided by 296 leaves 75 as a remainder, when the same number is divided by 37, the remainder will be. That has been asked in the CBI examination paper, and that we have here in the case that the options we have 1, 2, 8 and 11 as well. So in the same references that we'll talk about it. So here we go ahead with the solution as well. The solution we have at x equals to 296q plus 75, that is equals to 37 into 8q plus 37 into 2 plus 1, and which is equals to 37 into 8q plus 2 plus 1. So when the number is divided by 37, the remainder equals to 1 here. Now we'll go ahead with other question, which is the another one, that what we have to talk about it, and that is the another question. And in the term of it, that we have a boy multiplied 987 by a certain number and obtained 559981, that as his answer. If isn't and the answer of that both nines are wrong and that other digit are correct, so then the correct answer would be. So here we go ahead as as I told you, and that the question will go ahead here as well. So that for that options we have is your 553681, 555181 and 555681 and 556581. So here we go ahead with this, that is your 170 that we have 177th question of the session, that what we have to talk about it. The question is, a boy multiplied 987 by a certain number and obtained 55981, 559981 as his answer if in the answer both nines are wrong and the other digit are correct, then the correct answer would be, that what we have to find out. So let's go ahead with the solution, and that is the solution of this. We have to be before I am doing this particular question, you can just do your by yourself as well, so that you will be able to know that are you able to do it or not. But instead of those students, those who had new in this, and those who are weak in math, so for that I will be writing it. 987 is equals to 3 into 7 into 47. So the required number that must be divisible by each one of it, that is your 3, 7 and 47. So for 5, 5, 3, 6, 8, 1, that we have your option 1, that is sum of digit equals to 28. So that is not divisible by 3. The other option we have, which is 5, 5, 5, 1, 8, 1, which is sum of digits equals to 25, not divisible by 3. The other we have is your 5, 5, 5, 6, 8, 1, that is divisible by each one of 3, 7 and 47. So that will be right answer here. So we'll get that answer. We'll not further solve the other two options here as well. So that will be the right answer. Let's go ahead with other question, and that what we have here, and that what we have to even to solve it out as well. And that is the question we have is your how many 3-digit numbers are completely divisible by 6. So that I will be writing it out here, which is that is your 178 question of the session. In this, how many 3-digit number are completely divisible by 6? Options we have 149, 150, 151 and 166 here. So in that question pattern, that what we have the solution for this, that the 3-digit number that is divisible by 6 we have, that is to be as follows, which is 102, 108, 114 till 996. So this is an AP in which A equals to 102 and that D equals to 6 and L equals to 996, and let the number of the terms of n that we have, and that is we have then T of n is equals to 996. So we'll go ahead with A plus n minus 1 D, which is 996, that is equals to 996. Further 102 will put the value 102 plus n minus 1 into 6 equals to 996. The other we have, which is further 6 into n minus 1 equals to 894, because then it will go 102 go here side, that it will minus it out, we get it out as well, that is n minus 1, that is equals to 149, that is equals to n equals to 150 here as well. So the number of the terms equals to 150. Now we will go ahead with other question, that is the another one which we have asked here, and that is your 179th question of the session. That is your 179 question of the session that we have, and that is the sum of first 45 natural numbers. So in this, the options we have 1035, 1280, 2070 and 2140. So we'll go ahead with the solution of 120 that we have your 178 question of the session, that what we have to talk about it, and that let's go ahead here. So this is your let Sn equals to 1 plus 2 plus 3 plus till 45, that they had limited. So this is an AP series where A equals to 1, D equals to 1 and N equals to 45, and the last number is equals to 45 as well. So we'll do ahead where the formula will apply as N equals to N by 2 A plus L and which is your 45 upon 2 into 1 plus 45, and that is when we cancel it out, 2 ones are 2 से तो नहीं जाएगा, we'll add in on 46 and we'll cancel it out, that will be 23, it will break it out and then it will be formed here. So when it is multiplied 45 by 1, that is your 45 by 1 only, but will separate it out as well. So that will become your in the same case, that will become 45 into 23, and that is equals to 900 plus 135 equals to 1035. So the required sum we have 1035 here. Let's go ahead with the other question, which is your the another one, that the sum of all even natural number between 1 and 31 is, that what we have to find out. Let's go ahead. That is your 179 question of the session. The question is the sum of all even natural numbers between 1 and 31 is, the options we have 16, 128, 240 and 512 here as well. Let's go ahead with the question here. So that is the required sum equals to 2 plus 4 plus 6 plus till 30, and that is, this is an AP where A equals to 2, D equals to 4 minus 2, which is equals to 2, and L equals to 30. So let the number be the terms of then N, then Tn equals to 30, which is A plus N minus 1D, that is equals to 30. So we have 2 plus n minus 1 into 2 equals to 30, that will give n minus 1 equals to 14, which is equals to n equals to 15 here. So for that we'll apply the Sn formula, which is Sn equals to n by 2 A plus L equals to 15 upon 2, 2 plus 30 equals to 40, and that is your that will be the right answer. 240 will be the right answer for this question here. We will go ahead with other question, and that is your 188th question of the session. So in the terms of 188th question of the session, the series we have here, which is 51 plus 52 plus 53 plus till 100, that we have equals here, and that is the options we have as follows, which is 2525, 2975, 3225 and 3775. So here we go ahead, which is, we will solve it out as well. This is an AP in which A equals to 51, L equals to 100 and N equals to 50. So sum equals to n by 2 A plus L, which is equals to 50 upon 2 into 51 into 100, that is equals to 25, 50 plus 1 plus 100, that is your 151, that is equals to 3775 here. Let's go ahead with the other one, that is the another question, which is your 181th question of the session here. So let's go ahead with that as well, and that is 1 minus 1 by n plus 1 minus 2 by n plus 1 minus 3 by n plus up to n terms, and that we have an option 1 by 2n, 1 by 2 n minus 1, 1 by 2 n, n minus 1, none of these. So here we go ahead with solution. So here given sum equals to 1 plus 1 plus 1 plus till n terms minus 1 by n plus 2 by n plus 3 by n plus till n terms. So that is, we get n minus n by 2, 1n plus 1. So here L equals to nth term equals to n by n into 1, that is equals to 1, that we cross it off. And here n minus n plus 1 upon 2 n2, that is equals to 1 by 2 n minus 1. Now we'll go ahead with other question that what we have to talk about it, which is your 181th question, 182th question of the session. So that we have here, and that what even though we have to discuss about it, which is 182th question of the session. How many natural numbers are there between 23 and 100 which are exactly divisible by 6 here? And the options we have 8, 11, 12 and 13, and none of these. So here we go ahead. How many natural number are there between 23 and 100 which are exactly divisible by 6. So the options, as I told you, 8, 11, 12 and 13, and that is none of these. So we'll go ahead with solution here, and that we have the required number. We have 24, 30, 36, 42 till 96. So this is an AP where A equals to 24, D equals to 6 and L equals to 96. Let the number of the terms in it be n, and that is of Tn equals to 96, which is A plus n minus 1 D equals to 96. So that is a 24 plus n minus 1 into 6, and that is equals to 96, where in the same case n minus 1 into 6 equals to 72, which is equal to n minus 1 equals to 12, and that will minus will go here, and that will n equals to 13. So the required number will be your 13. That it will be the right answer for this question here. Let's go ahead with another one, which is your 183rd question of the session, that what we have to talk about it. So in the same cases, the question is that the sum of all 2-digit numbers divisible by 5 is. The sum of all 2-digit numbers divisible by 5 is, that is your 1035, 1245, 1230 times 45, and none of these. So we will go ahead with this, and let's solve it out as well. So that we will go ahead, and the required numbers are 10, 15, 20, 25, 95 here. So here in the AP we have A equals to 10, D equals to 5 and L equals to 95. In the same cases, let the number of the terms be n here, then we have G of n equals to 95, that is equals to A plus n minus 1 D, that is equals to 95. Put the value, which is 10 plus n minus 1 into 5 equals to 95, which is equals to n minus 1 into 5 equals to 85. We'll minus it out 10 as well. It will give n minus 1 equals to 17. Minuses will go here. It will n equals to 18. That will be the right answer for this question here. And for that, required sum equals to n by 2, A plus L. 16 by 2, 10 plus 95, which is equals to 9 into 105, and when we multiply, 945. The other question we'll do ahead, that is that the sum of how many terms of the series we have 6 plus 12 plus 18 plus 24 plus till 1800. The options we have 16, 24, 20, 18, 22. The sum of how many terms of series 6 plus 12 plus 18 plus 24 plus till 1800. So here we go ahead. This is an AP in which we have A equals to 6, D equals to we have 6, and Sn equals to, which is equals to 1800. So here that is then we can say that n by 2 2a plus n minus 1 d equals to 1800. So n by 2, that we have 2 into 6 plus n minus 1 into 6, which is equals to 1800. That is equal to 3n, n plus 1 equals to 1800. And here we have n by 2, that is here itself will go ahead, and that is your n plus 1 equals to 600, n square plus n minus 600 equals to 0, which will give n square plus 25n minus 24n and minus 600 equals to 0. So here we have, that is n plus 25 and n minus 24 equals to n equals to 24. That will be the answer here. So the number of the terms is 24. Let's go ahead with other question, that what we have to talk about it, which is 185th question of the session. So I just let you write the questions here, so that will continue with this as well. So that we have 185th question of the session. The question is, how many terms are there in the GP 3, 6, 12, 24 till 384? So how many terms are there in GP? And that we have the GP here, that is 3, 6, 12, 24 until 384. So in the same we have an option 3, 9, 10, 11 and 7 here. So in the same cases we go ahead with the solution, in the same references that we have A equals to 3 and your R equals to 6 by 3, which is your 2, and your let the number be the terms n, so that Tn equals to 384. So we have, that is your AR, the formula we have AR n minus 1, which is equals to 384. Let's solve it out. That is your 3 into 2 power n minus 1 equals to 384, which is equals to 2n minus 1 equals to 128, and equals to, that is your 2 power 7. So we can say that n plus 1, sorry, n minus 1 equals to 7, and that will go n equals to 8 here. That will be the right answer for this question as well, as you can see here. So, okay, so that will be the right answer. The number of the terms we have is your 8. Let's go ahead with other question, which is your 186th question of the session. Here we go ahead with 186th question of the session, and that is 2 plus 2 square, 2 cube and plus till 2 power 9, that we equals to have a series, that is 2 plus 2 square plus 2 cube plus till 2 power 9 equals to question mark. So that the options we have 2044, 1022, 1056 and none of these, and for that we will be solving it out as well, the question as well here, and that we have as follows. which is, this is a GP. Here we have A equals to 2 and R equals to 2 square by 2, so that is your 2 to the 4, so 4 1 the 4, 4 to the 8, that is, and N equals to 9 here. So we'll put the formula here, that is Sn equals to, for the GP we have formula A R power n minus 1 upon R minus 1, and that is equals to 2 into 2 power 9 minus 1, 2 minus 1, and that is equals to 2 into 512 minus 1, which is equals to 2 into 511 equals to, that will multiply, 2 ones are 2, 2 ones are 2, and 2 5s are 10. So 1022 will be the answer here. Okay, so in the same case we'll go ahead with other question that we have to talk about it, and that is the another question, which is your 187th question of the session. In 187th question of the session here, and that we have here, that is your 1 square, 2 square plus 3 square till 10 power square here, that we have 1 square plus 2 square plus 3 square plus till plus 10 power square here, that we have to find it out as well. In the same case, the options we have is your, that is your 330 plus 345 and 365 and 385 as well. So in the same cases we'll go ahead and with the solution, and that we go as following. That is, we have followed that solutions. We'll talk about it. We know that 1 square plus 2 square plus 3 square plus n square, that is your equals to 1 by 6 n plus 1 and 2n plus 1 as well. So in the same case we'll put n equals to 10, that what they had mentioned you here. So the required sum equals to 1 upon 6, that is multiply 10. So it is 10, then 10 plus 1 11, 10 plus then multiply 10 plus to 20 plus 21, so that is 10 into 11 into 21. So when we'll go ahead with this, so it will be your 385. That will be the solution of this. Let's go ahead with other one, and that is the another question we have to go through with that, and that is your 188 question of the session. And the question is 2 power 2 plus 4 square plus 6 square plus 10 plus 20 square, that is equals to question mark. The options we have 770, 1155, 1540 and 385 into 385 here itself. So that is, we'll talk about it, the solution, and which we have as follows, and that we go ahead, which is 2 power 2 plus 4 power 2 plus 6 power 2 plus till plus 20 power 2, and that is equals to 1 multiply 2 power 2 plus 2 into 2 power 2 plus 2 into 3 power 2 plus till 2 into 10 power 2 as well, and that is equals to 2 square multiply 1 square, that is plus 2 square into 2 square plus 2 square into 3 square plus 2 into 10 power square here, and that will be 2 square into 1 square plus 2 square plus 3 square plus still plus 10 square as well, and that is equals to 4 into 1 by 6 into 10 into 11 into 21, and that we can say that 1 square plus 2 square plus 3 square plus till n square equals to 1 by 6 n plus 1 and 2n plus 1 as well. So that will be 4 into 5 into 77, and that is equals to 1540. Let's go ahead with other question, that what we have to talk about it, and which is another one and the last question of the session as well. That is your 189 question of the session, which we have, that is 11 square plus 12 square plus 13 square plus 20 square. That will give an option here, that is 385, 2485, 2870 and 3255. We'll go ahead with solution as well. So that we have the series is equals to 1 square plus 2 square plus 3 plus 20 square, that minus 1 square plus 2 square plus 10 square, that is equals to we have 20 into 21 into 41 upon 6 minus 10 into 11 into 21 upon 6. So that will give the series we have. So the series we have here, that is your 1 square plus 2 square plus 3 square plus still plus n square equals to 1 upon 6 n plus 1 to n plus 1 as well. So with the same cases we have to 870 minus 385, and that is equals to 2485. So here we'll end up with this, that we had completed the operations on numbers, and in the next coming class we'll start with SCF and LCM as well. So here in this, as an aptitude, quantitative aptitude, in a section 1, the arithmetic ability, we had completed the first topic, which is your numbers here. In this we had discussed numbers. We'll start with SCF and LCM of numbers. We'll start discussing about the decimal fractions, simplifications, square roots and cube roots, average, problems on numbers, problems on ages, surds and indices, percentage, profit and loss, ratio and proportion, partnership, chain rule, time and work, pipe and cistern, time and distance, problem on trains, boards and streams, allegations or mixtures, simple interest, compound interest, logarithm, area, volume and surfaces area, and that is your races and games of skills, calendar, clocks, stocks and shares, as well as permutation, combination and probability to discount, bankers discount, heights and distance, odd man out, and series as well. After that we'll discuss the data, second section, that is your data interpretation. We'll discuss about tabulation, bar graph, pie charts, line chart, line graph as well. Other than that, we are dealing with reasoning, where we had covered up the verbal reasoning, which is your general mental ability, and logic reasoning, and then we had started with non-verbal reasoning, which where we had covered up the series, and we had started with analogy as well, and that is you can stay tuned with us, and thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.